Hello, everybody. Welcome to my last live stream that I have to do this year. God, I've already done 3 live streams, and here we are for live stream number 4. It's probably going to be my most popular one. AP Precalculus students, how are we feeling today, everybody in the chat? Please tell me, how are we? It's the night before the exam. How are we doing? Oh my gosh. How are we doing, guys? Man, this is rough. Guys, hello. Oh my gosh, I just had to do a 2.5 hour psychology live stream just about an hour ago. I just did that, so I'm back here. We're doing this. It's just so much work, guys, but we're here. Unprepared, scared, bad, cooked. Okay, I've seen a lot of people say that they're not prepared. A push SAQs were light. Okay, good. All right. Screwed, horrible. All right, come on, guys. You're going to do fine, all right? Listen, all right, I got to do a few introductory things before we actually get into content stuff, so just give me 1 second. First of all, how many people do we have actually in here? 600 people. Lovely. I think we might actually get past 1,000 concurrent viewers tonight. That'd be crazy. All right, so welcome, everybody. Welcome to the live stream. So today what we're going to do is I stayed up really late last night, and well, actually, essentially, so what I did is that last year we did live streams for AP Precalculus. That's the only course I did live streams for. I did units 1, 2, and 3. Now, I'm not going to make those live streams public or anything because they were pretty bad. I'm going to be real with you. But this year we're just doing 1 live stream for all of the units. So what I did was I searched up practice exams, official College Board release practice exams. Now, you might have already had some exposure to these questions, but the point is that what you think is going to be on the practice MCQs, what your teachers has made to be on your practice MCQs, it is not really that bad. It's actually quite a lot easier than I'm sure you think. When I took the AP Precalculus exam 2 years ago, they gave us 80 minutes to solve all the, I think, 27 questions. Everybody was done a half hour early. It was so easy. It was so unbelievably easy. I promise you, your teacher has made this course so much harder than you think it is. And that will be showcased as we go through actual MCQs today. So we're going to go through MCQs today. We're going to be doing AP Precalculus. A few disclaimers. We have a moderator. We have moderators in the chat. So if you just be prepared. If you say anything bad, if you try and promote something bad, if you call me Young Sheldon, don't do that. You will get timed out. And or banned. So just remember that. Also, we have a lot of people here. I just want to point out we have like 700 people. It's going to go even higher. There's a lot of people here. I'm not going to be able to appease every single person in this live stream. I'm only going to be trying to do what I can. So I apologize. If any time you feel like this live stream's not worth it, you're not getting anything out of it, you don't have to stay at all. Feel free to leave. I'm not going to be offended. There's 700 of you in here. I can't surely be here for everybody. The point is, if you want to review this course, I'm a video editor by trade. If you want to review this course, I have a video on my channel. It's an hour long. It covers the entire AP Precalculus. It's a great video. I really wish for you guys to watch that. But that being said, we are going to cover AP Precalculus today. So the idea is, we have an MCQ that we are going to cover. Now, this MCQ, if you're wondering, this is in the description of this video below. We are going to go through this together. If you want to follow along with me, it is in the description below this video. You high-key look like Young Sheldon. Time out that guy for a minute, please. Young Sheldon is actually a compliment dog. Fine, you won't get timed out, but still. All right, anyway. So the idea here is that we are going to go through an entire practice MCQ. I think this is like 13 pages long or something. Yeah, 13 pages long. And then we are going to go over FRQ 4 because that's the one FRQ review that I didn't make. So we're going to go over the 2025 FRQ 4 that I made. And yeah, so people, we are going to go through this now. How shall we start? I suppose we should start with this first question. All right, let's start it out. So this is no calculator required. So I was told that you have Desmos, that you get to use Desmos. I didn't get to use it on my exam, but if you have Desmos, then that's cool. We are going to be doing everything on a graphing calculator today. But yeah, no calculator allowed on this part of the exam, just so you know. All right, here we go. All right. Let f be a sinusoidal function. The graph of y equals f of x is given in the xy plane. What is the period of f? Period, remember, it is how long it takes a graph to complete one cycle. So you either choose one minimum and see how long it takes to go to one minimum. So I choose this minimum at -1, and then I go 3 to negative 1. A way to do this is to take the second one and subtract the first one. So I do 3 minus negative 1. If I do that, that 3 minus negative 1 is 4. Or I go to maximum. So this is at 1. This is at 5. So I do 5 minus 1, and that equals 4 again. And that's because it takes 1, 2, 3, 4. So that is how long it takes to complete one cycle, period. So the answer is C to start off. Okay, let's continue. The function f is given by f of x is equal to 5x to the 6 minus 2x cubed minus 3. Which of the following describes the end behavior of f? So remember end behavior. End behavior in a polynomial function is determined by three things: the leading coefficient, and the degree of the first coefficient. So here we see we have a positive leading coefficient, and our degree. Sorry, I should say this. Oh my God, I put 2. I'm so bad. Our degree is 6, which is even. So we have an even degree. We have a positive leading coefficient. So because of that, our end behavior, our graph is going to look something like this. Now, I'm not going to sketch out an exact graph. 6, there's going to be a lot of curves in it. Basically, the end behavior is going to go up this way and up this way. Now, how do I know this? Because I know the table of values. If it's even, they're both going to end on the same way. So these both go to infinity. Both go to infinity here. So that means the limit as x approaches infinity of f of x is going to approach infinity. And the limit as x approaches negative infinity of f of x is going to approach negative, or not negative infinity, it's going to approach positive infinity, just like that. So because of that, both the answers are positive infinity, so this is negative infinity, can't be A. This is positive, B. There we go, B is the answer. That's how we started off. Let's keep going. Fake AP, by the way, get a timeout on that guy. Consider the functions f and g given by f of x equals the log base 10 of x minus 1 plus log base 10 minus that whole function there, and g of x is equal to this log function. In the xy plane, what are all the x coordinates of the points of intersections of the graph of f and g? So the way you have to do this is you have to set each of these equal to one another. So I have to set f of x equal to g of x. I'm going to change colors here to red. So the f of x function, what was it? It was log base 10 of x plus, x minus 1, I should say, plus log base 10 x plus 3. And that was the whole f function. So now we have to set it equal to the g function, which is log base 10 of x plus 9. Okay. So we set the left and the right functions equal to one another. So now we just need to know our log rules. Because these are two logs of the same base that are adding together, I know that the log rule here is going to be the product rule. So the product rule says here that I can do 1 log base 10, and then I multiply these two together. So I multiply the x minus 1 multiplied by the x plus 3. I don't need to have the plus in the middle because that's the product rule. And then that would equal, of course, the log base 10 of 9 of x plus 1 plus 9. Lovely. So now, what does this equal? Well, the idea here is because all these have the same base, I could put 10 beneath these and make these, I could put a 10 like this, erase these sides, both the power, and this will cancel out the log because they have the same base. So canceled out. And so now I can just bring these down. So we don't need the log anymore. So x plus 1, or x minus 1, x plus 3 is equal to x plus 9. So now I want to arrange this into one equation in standard form. So let's FOIL here. What do we get for foiling? X squared minus 3 plus 3, so that's plus x, or minus 1 plus 3. Yeah, that would be minus x because that's, or plus x, sorry. So I get, for this form, it would be x squared plus x minus 12, or plus 2x, I should say, sorry, plus 2x minus 3. That's what I would do. I've just FOILed these two. I multiplied these by one another. And then that would equal the x plus 9 All right, so now we have to subtract x from this side and then subtract 9 as well. So we get x squared plus x, because we subtracted the x. We subtracted the 9 too, so we get minus 12. So this is our standard form equation. Now the way to find where all these zeros are is, well, we have to set this equal to 0. So we get x squared plus x minus 12. We set this equal to 0. We factor this. We get x plus 4. And we get x plus minus 3. All right, x plus 4, x minus 3. Set those both equal to 0. We get x equals negative 4 and positive 3. Okay, negative 4 and positive 3 are going to be our answers here. But I want you to notice something. Negative 4, when we do any sort of log expression, we always have to check our solutions, because negative 4 as a whole is what is known as an extraneous solution. Now, why is it extraneous? Because if we plugged negative 4 back into log expressions earlier, like this negative 4 minus 1, that would create a negative output value. And you can't take the log of a negative number, meaning this negative 4 cannot be a solution. It's extraneous to this log circumstance. So that would mean that our only answer is going to be this one, the x plus 3, or sorry, the x equals 3. That is our answer. So x equals 3 is our only answer to this one, so our answer is going to be A. Lovely jubbly. Okay. Next one. Yeah, I want to make sure you guys can see this whole thing. We got to go fast? We don't got to go fast. We're going through. I think I'm going at a decent pace. Okay, so the figure shows the graph of the function f. The 0 and extrema for f are labeled, and the point of inflection of the graph f is labeled. Let a, b, c, d, and e represent the x-coordinates at those points of the following, of which interval is f increasing and the graph of f is concave down. So we're looking for f. F has to be increasing, and f has to be concave down. Okay, so if you remember, for f to be increasing, that means that the derivative of f has to be positive. So, oh wait, sorry, that's calculus. Sorry, I just did a calculus stream earlier this week, like yesterday. Sorry, that's calculus. Sorry, we're not doing calculus. So f is increasing. So we see on this graph that anytime it's going up, that it would be increasing. Anytime that it's concave down, remember, concave down is anything that looks like that. Concave up is anything that opens inward. So I like to think it's like an umbrella. Concave down, if we spilled water on top of this, it would spill down the umbrella. So if it hits, it's going to spill down the umbrella. Concave down, if we spill water on it, it's going to collect the water like that. Okay, so it's like a bucket versus an umbrella. Okay, oh, sorry, you can't see that, can you? So where is it increasing? It is increasing from A to B, and it is also concave down, because this is the water would be poured down. So A to B, it is concave down, so our answer is going to be A, pretty simply. A to B is the interval here that is concave down and increasing, A to B. Okay, next one. Let's move me back up here. Welcome back. Oh my God, we have over 1,000 people in this live stream. That's awesome. All right. The polynomial function p is given by p of x is equal to negative 4x to the fifth plus 3x squared plus 1, which of the following statements about the end behavior of p is true. Remember, end behavior is leading coefficient and degree. So we have a negative leading coefficient, and the degree is odd. It's 5. As you can see, negative, and we have 5. So because it is negative, that means it's going to be reflected. So a negative odd function, I'm not going to write down the exact graph, but it would look something like this. Now, of course, this isn't an exact representation of the graph, but you get the idea. It's going to be increasing towards this way and this way. So that means the limit as x approaches infinity of this function, as x approaches infinity, it's going to go down to negative infinity. And then the limit as x approaches negative infinity, f of x is going to be approaching negative infinity, f of x is approaching positive infinity. Okay, let's look for the answer that leads to this. The limit as x approaches infinity. Nope, not this one, not A. B, limit as x approaches negative infinity. Okay, it's not B. C, negative infinity. Wait, did oh, sorry, I misread this. Sorry, it's, let's see here. I want to try B again. Negative infinity, positive infinity, infinity, negative infinity. So it looks like the answer here is actually going to be B. Why? Because these two limit expressions, or sorry, gosh, I just blocked it. These two limit expressions are equal to the ones we just did. Okay, let us continue. Trigonometry. How fun. I'm going to have to zoom out a little bit here. So the figure shows a circle centered at the origin with an angle measure theta radians in standard position. The terminal ray of the angle intersects the circle at point P, and the point R also lies on the circle. The coordinates of point P are x comma y, blah, 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 and the coordinates of point R are x comma negative y. Which of the following is true about sine of theta? Okay, I want you to remember something that we covered back in topic 3.2. So here, I want to switch colors. Let's go here. Sine of theta. Now, what is this equal to in the, or sorry, just sine in general? What is this equal to in the greater world? Well, we know sine is equal to opposite over hypotenuse. Opposite over hypotenuse. In the unit circle, that means sine is equal to y all over x. So that would mean, in this case, x is just the r that goes out to the terminal circle here. So x would be equal to r, so it would be y over r. All right, that's good to know. Gosh, sorry. So what does this tell us? We see our x here, 5, is r. So r here is going to equal 5. And it's asking us which of the following is true about sine of phi. So sine of theta is equal to x over 5, negative y over 5. So remember, we just figured out it's y over r. We know r is 5. So it would be equal to, y over 5. That would be our answer here because we know the way sine goes. And we figured out sine is our x coordinate here. So y over 5 is our answer. Blah, blah, blah. Nope, nope, nope. Yes, right here. D, 5 is our answer here. And why is it? Because the ratio of the vertical displacement of P from the x-axis to the distance between the origin and P. There you go. That is our answer. All right, another log expression. I remember somebody in chat said that they were cooked on logs or something. Here we go. We're going to go through all the rules here. We're going to switch to red. So, which of the following is equivalent to log base 10 of this? So we got to expand this out. We're doing the opposite of what we normally do. Log base 10 of kz over w squared. Yeah, like that. Okay. Now, what is this equal to? First of all, we can do the quotient rule because these are dividing by one another. Not the quotient rule, that's calculus. We can say that it's equal to two terms subtracting from one another. So log base 10 of the numerator, kz, minus, because it's dividing, minus log base 10 of w squared. Just like that. So that's the first thing we can do. And then how can we rearrange this? Well, let's see. This right here, we have a k factor multiplying by z. Because these are multiplying, we can use the product property. That means we can expand these out to be two that are adding together. So we get log base 10 of k plus, because it's multiplying, log base 10 of z, and then we have to keep this one minus log base 10 of w squared. But remember, what we can do is the product property here. The product property basically says this 2 can move all the way over to the front here, and it will be the same thing. So I'm going to delete the 2, and I'm going to move it over to the front. Now, is this would probably be our fully simplified answer. So is this any of our options here? No. Log base k plus 2. Nope. Minus 2 log base 10. Oh, I think it's there. This right here, B, is equal to the one we just figured out. This one right here. That is why the answer is B. Do you play Persona 5? I do. Thank you for asking. Even if your message got deleted. Okay. Polar. A lot of you guys were asking for polar, so we're going to do some polar now. Welcome for polar. Oh, I have emotes in my chat? I didn't even know. All right, polar. Here's your idea. Well, let's read the question first. The figure shows the graph of the polar function r equals f of theta, where f of theta is equal to 4 cosine of 2 theta. In the polar coordinate system for 0 to 2 pi, there are 5 points labeled A, B, C, D, and E. If the domain of f is restricted to 0 to pi over 2, the portion of the given graph that remains consists of two pieces. One of those pieces is the portion of the graph quadrant 1 from C right here to E right here. Which of the following describes the other remaining piece? Now, really quickly, there are 2 ways you can examine this one. Now, the way that you could examine this is to split the domain in half. So you have 0 to pi over 2. So why don't we figure out what the domain from 0, where should I remove myself? 0 to, theta to pi over 2 is. So figure out on that specific interval, we would have to figure out what the values were, and then we could kind of figure out where the next one would come from. But the easier way I like to do it, it's so much easier this way, is that I simply just draw a graph, because we already should know how to draw a sinusoidal graph. So let's draw a graph really quick. Okay, so we have an amplitude of 4. The amplitude is the distance between the middle line to the maximum. So we have 4, -4, and then 0. We have the period is 2 pi over the period. That would be equal to this 2 theta. This one in the middle, 2. So the way we would get that is just to put a pi on the bottom, so the period's pi. And then we could construct the pi over 2. What would this be? 3 pi over 2? No, that wouldn't be pi over 2, sorry. It would, 3 pi over 4, I should say, gosh. Okay, and then pi over 4. Now, the idea is that, I'm not going to do this whole thing, but when I construct this graph of the cosine graph, is that when I construct this, it's going to basically, if I convert this to a polar coordinate system, where we go 4 to 0, so we go to 4 to pi over 4 is 0. Sorry, this is going to be pi over 2. I did the period wrong on this one. So 4 to 0. The next thing that we would sketch is going to be this one, because this is a rose. So when we start by sketching a rose, we'll switch to a different color. We go 4 to 0. Then the next thing, what do we sketch on the rose? We go here. That is what we go next. So we have one interval where we go here to here. We have another where we go here to here. Okay. So this interval is the one we're looking for right here. This one right here. Where is that going to? E to D. E to D. E to D is quadrant 3 at E to D right here. That is the next part that is being graphed here, the other remaining piece. We have C to E as our start one, C to E. Now the next piece in the interval pi over 2 is going E to D. Okay. Consider the graph of the polar function r equals f of theta, where f of theta equals 1 plus sine of theta in the polar coordinate system. Between the intervals 0 to 2 pi. Which of the following statements is true about the distance between the point with the polar coordinates f of theta and the origin? It's asking whether the function is increasing in positive or something like that. So the idea is that the distance from a point to the origin is going to be equal to the absolute value of r. The absolute value of r is this is the distance from the point to the origin. So first we have to check where r is positive and negative. So the way we do this is we take our sine equation that we had earlier and we set this equal to 0. So we do 1 plus 2 sine of theta and we set this equal to 0. Now, we can rearrange this. If we subtract the 1 and divide the 2, we get sine of theta is equal to 1 over 2, negative 1 over 2, I should say. And now, if you know your unit circle, you should be able to see this in arc sine equation. So if you know your unit circle, you should automatically spot that theta is equal to 7 pi over 6 here. And also 11 pi over 6. That's because I know my unit circle. The reason why it's not plus 2 pi k is because we are within this interval 0 to 2 pi. All right. So now that we know these values, you might be asking, why do we need to know these values? The idea is that whichever one of these has a greater value is going to be positive, whichever one's blah, 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 negative. So we plug in a value between these intervals, and we figure out that, so when r is positive on, r is greater than 0 on the interval 0 to 7 pi over 6, because that is our 0 of our function, 7 pi over 6. The way I would find this is I would plug in any number within this interval, and I would essentially, sorry, I guess this side wouldn't have brackets. I would plug it, and I would figure out if r is positive or negative. Here we find that it is positive in this interval. And then on this side, r is negative. Why is r negative? Again, because I plugged in the 0. So this one, oh, sorry, I wouldn't include it, would it? 7 pi. And we are going to where? 7 pi over 6. This is our 0. We're going to 11 pi over 6. We basically just kind of made a sign chart here. We went from one interval to the other. So we went 0 to 7 pi. So we know which intervals they are positive on. So if we look at A here, the distance is increasing for 0 to pi over 2 because f of theta is positive and increasing on that interval. So A is positive, and also sine of x increases on the interval 0 to pi over 2. So A is actually going to be our correct option here. Why? Because A is a positive function because it is above the x-axis. We just figured that out. But we also know it is increasing because sine of x increases on the interval 0 to pi over 2. You have to know your sinusoidal equations for this one. The answer is A. You got it. The answer is A. Sorry, polar functions, a little bit janky, but we're getting through them. Next question. We're going to go back to blue here. There's 1,000 people in here. That is so crazy. All right, whatever. The polynomial function p is an odd function. If p of 3 is equal to -4, or if p of 3 equals -4 is a relative maximum of p, which of the following statements about p of -3 must be true? All right. You got to remember the odd and even properties. What is the odd property? The odd property is that p of -x is equal to negative p of x. This could be f, it could be whatever variable you want. So this is the odd property. So what we are given here is that p of 3 is equal to -4. So with the odd property, what we can do is rearrange this. So we can rearrange this with this odd property that we just found out into p of -3 is equal to +4. Why are we able to do that? Because of this property that we just went over. So we just swap the signs essentially. Now because we did that, we see that there is I mean to say that a relative maximum at 3, 4, I should say -4. Why is this a relative maximum, you may ask? Because it's just the higher of the two. This was the original function we were given, 3, -4, this original point we were given right here. This is a relative maximum or a local maximum, relative maximum. This one right here that we just figured out with the odd property, the -3, 4, this would have to be a relative minimum because I want you to think about how, I want you to think about how an odd function works. An odd function has rotational symmetry around the origin point. So if we rotated the entire x graph, this odd property, what it's doing is making it so it's rotated to be a relative minimum. So that means this is going to be a relative minimum. Just like that. So we get the answer, f of p of -3 equals 4 is a relative minimum, not a relative maximum up here. So the answer is C. Cool. Or sorry, not the answer is C. I mean to say it's A. Did I switch these two? Oh my God, I did switch these two. Thank you guys for realizing in the chat. I just realized I swapped these two. Relative, because this is the y coordinate is the negative. So this actually, sorry, I'd swap these two. Thank you guys for finding this out in the chat. I appreciate it. This is a relative minimum. Why is it a relative minimum? Because this is a -4 here. The -4 is going to be 4 under the y-axis. This is 4 above the y-axis, which is why it's a relative maximum. Okay, sorry. Thank you guys for figuring that one out for me. I appreciate it. But yeah, we have the odd property. We just rearranged it. That's how we did it. Okay. All right. This next one, 9. Values of the terms of the geometric sequence g sub n are graphed in the figure. Which of the following is an expression for the nth term of the geometric sequence? Now, of course, what we could do is build a geometric sequence equation. We could just do that right now. But we don't need to. We genuinely don't need to. Why don't we just pick a point? How about this one? This point right here. 3, 2. Now, what I'm going to do is I'm going to plug that point into each one of these problems. Now, if we plugged in, let's see what happens if we plug in 3 for n. So if we plugged in 3 for n in each of these, our output value we get needs to be 2. So let's plug it in on this first one. 3 minus 2 is 1. So 1/2 to the 1 power is just 1/2 times 4 is 2. So we know our first one is going to equal 2, which is our output value that we were given, so A is likely correct. Let's check the other ones, though. N minus 1, we do 3 minus 1, we get 2. 2 to the 2 power is 4. Multiplied by 8 is going to be, 4 times 8 is 32. So this one is not right. B is not right. C, G sub n is equal to 8 over 1/2, so we do n to the power of 3. So 1/2 to the power of 3 would be 1 over 8. 1 over 8 times 8 is equal to 1, so this wouldn't be it. Finally, G sub n is equal to 16 1/2. So n minus 1, so 3 minus 1 is going to be 2. 1/2 to the second power is 1 over 4. 16 times 1 over 4 is 4, not 2. The only one we got the correct output value of 2 when we plugged in 3 was at A. That is why A is going to be our answer. We didn't even have to solve for a geometric sequence. We just plugged in the values. Going through this a lot faster than I thought I would. All right. Here we go. A food vendor developed a new sandwich type of sale. The vendor made estimates about the sales for the new sandwich over time. A linear regression was used to develop the model for the sales over time. The figure shows the graph of the residuals of the linear regression. Which of the following statements about the linear regression is true? Okay, people, remember, the idea of residuals is that if a residual shows a definite pattern, like for example, in this case, we see a definite pattern. It is a downward facing quadratic function. If residuals have a definite pattern, that will mean that the original function that the residuals were created from is not a good fit for your model. A good residual plot, something like this, a good residual plot would just have the points scattered all about. This would be a good model right here. But if it resembles a pattern, the residuals are not a good model. So that means the linear model is not appropriate. This one right here, the linear model is not appropriate. And why? But there's 2 of them that says not appropriate. So is appropriate? No. Is appropriate? No. So we have 2 not appropriate, so let's read the answers. Because there's a clear pattern in the graph of the residuals. That is obviously correct, so it's going to be A. B, because the graph has residuals has more points above 0 than below 0. That doesn't matter at all. We don't have to worry about that, so it's not B. The answer is A. Okay, there we go. The linear model is not appropriate because it shows a clear pattern. Let's keep going. Which of the following function has a 0 at x equals 3 and has a graph in the xy plane with a vertical asymptote at x equals 2 and a hole at x equals 1? So I want you to imagine what a rational function would look like. Zeros come from the numerator. So first of all, and if we had a 0 of x equals 3, I'm going to know that I'm going to need a 0 of x minus 3, because it's always the opposite, in the numerator to start off. Now, a hole means that you have two zeros matching in the numerator and denominator. So what I'm going to do for a hole is I'm going to match them. I'm going to do an x minus 1 again, because remember, we have to match it. We have to do the opposite. And then there also has to be an x minus 1 in the denominator. And then a vertical asymptote also comes from the denominator. So we would have a vertical asymptote x equals 2, so x minus 2. Just like that. And so if we were to multiply these out, gosh, what would this be? It would be x squared minus 3x minus x plus 3. That would be the FOIL here. All over, what would that be? X squared minus 2x minus x plus 2. So if I were to take this down here, If I were just to simplify this, we get x squared minus 4x plus 3 all over x squared minus 3x plus 2. Is this any of our answer options that we see up here? X squared minus 4x plus 3, x squared minus 3x plus 2. Oh, it's A. Okay, then it's just A. That's our answer. Why is it A? Because we built our function earlier. Let's see if I can connect these arrows. Oh, so beautiful. So we built our rational function from earlier, knowing our things. We multiplied them out. Or you could just factor the numerator and denominator on each of these, but I like the way I did it better. Really quickly, I have people in the chat asking how long this stream is going to be. It's probably roughly going to be around 2 to 3 hours. I know you guys need a good night's sleep, so for my people on the East Coast, 3 hours lands exactly at 11 p.m. where you can go to sleep, get a good night rest. So that's the plan for today's stream. But anyway, let us continue with the stream. It might, 2 to 3 hours, somewhere around there. Here we go. The figure shows the graph of a sinusoidal function g. What are the values of the period and amplitude? Okay, easy. Period, we do maximum minus the past maximum. So this is at 11, this is at 3, so we do 11 minus 3. Gosh, that's such a big minus sign. 11 minus 3, which is 8. So that's our period. That would be our period. For our amplitude, that is going to be the distance from our midline to our maximum point. So our midline here is at 0. So the midline to our maximum point, that's going to be 0 to 3. So 0 to 3, that would just be 3 is our amplitude. Okay. Period is 8. Amplitude is 3 is answer number B. Just like that. All right, let's move on to the next problem. We're already halfway through this. Let me go take a swig of water really quick. All right, let's continue. So iodine 131 has a half-life of 8 days. In a particular sample, the amount of iodine 131 remaining after d days can be modeled as a function given by h of d is equal to that, where a sub 0 is the amount of iodine 131 in the sample at time d equals 0. Which of the following functions k models the amount of iodine 131 after remaining after t hours, where a sub 0 is the amount of iodine 131 in the sample at time equals 0. Now, guys, I want to be very clear here that this is not that difficult. The d over 8 here means, the d over 8 here means 8 days. So we need to convert these 8 days to hours. That's the idea. These 8 days, we need to convert that to hours. And so we are given that there are 24 hours in a day, so t equals 24d. The idea here is that we need to set d right here. D would be equal to 1 over 24. Now, why? Sorry, my goodness, I lost my train of thought. Why is it, sorry, not 1 over 20, t over 24. Now, why is this t over 24? Because there are 24 hours in the day. So we just need to set this d equal to t over 24 in the original function. So a sub 0 of 0.5. But then we have to set the d equal to t over 24. But then that is all going to be over d over 8. Okay. Sorry, not over d over 8, because we replaced the d, not d over 8. It's going to be equal to just 8, because we have an 8 in the denominator here. Okay, so now all we have to do is simplify this numerator. So this is going to be a fun chat. Here's a question for you. How do you simplify this fraction right here? What is the answer to this fraction right here? The half-life doesn't really matter here. We're more focusing on the days and function to hours. How do we simplify this fraction here? Damn, I hate the ads, bro. Sorry, I can't really do much about the ads. I'm actually being so genuine. I tried to turn them mostly off for the stream. T over 3, wrong. T over 3, wrong. You guys got this wrong. Because I want you to imagine you were how do you say this? Copy dot flopping? Whatever. It's a very interesting thing. So because you're dividing, if we switch this to multiplication, we have to switch 8 to the top. And then we would have to multiply this. We would copy dot flop again. Sorry, that's how I learned it. It's called copy dot flop. So this would actually be equal to 24 times 8. T over 24 times 8, which is T over 192. That's what 24 times 8 is. Now, that's just because it is a fraction divided by a whole number. That means you have to multiply these two together. That's just a common algebra knowledge that you guys should know. Okay, so T over 192, which is the only present in answer D. So the answer is D. That's because we have it right here. Okay, let's keep going. All right. What are all the values of x for which the natural log of x cubed minus the natural log of x is equal to 4? Here we go. So we need to, let's see, what are we given here to start off? We are given the natural log of x cubed minus the natural log of x is equal to 4. So I'm going to rearrange this with the quotient rule, which is the opposite of the product rule. So I'm going to do x cubed on the top minus 4. So we just have stuff, or divided by 4, I should say. Not 4, gosh, not 4. It's x. This term x here, the opposite of the product rule is equal to 4. We can actually simplify this in here. So we get the natural log of, if you're doing something divided by another, you are subtracting. So you get x squared in the simplification here is equal to 4. Okay. Now, you might wonder, how do you get rid of a natural log? What you do is you have to make the natural log the exponent of e. So we put e down here. Here, I'm going to put this in a different color. We put e down here, and what we do to one side, we have to do the other, so we do e to the 4th. So if we raise something to the power of e, that means this exponent completely goes away. Yeah, so this completely goes away, but we have to keep the e on the other side. So we get x squared is equal to e to the 4th. So what do we do here? Well, we have to square root. We have to square root. So we take the square root of both sides to get x on its own. And we'll bring this up here really quick. We get x is equal to the square root of e to the 4th would be equal to plus or minus, because it's the square root, e to the 2nd. So we have e to the 2nd and negative e to the 2nd as our answers. So where do we see that? We see that at letter number B. But wait a second. I want you to remember, what do we have to do whenever we do logs? We have to check for extraneous solutions. So this negative e squared, if we were to plug this into, like this one, the natural log of x, if we were to plug in a negative e squared, remember, we cannot take a log of a negative number. It's outside of the domain of a logarithmic graph. And so because of that, we can't take the natural log of a negative number. This negative e squared is an extraneous solution. You always have to check all your solutions if you're doing logs. So because that's an extraneous solution, our only answer is going to be this one, x equals e squared, which is c. Always check for your extraneous solutions. Why are the College Board practice MCQs way harder than this stuff? The reason is because this is what's going to actually be on the exam. As somebody who has taken this exam, I will be happy to tell you that it was so easy. The stuff I received in class was so difficult. It took forever. I have hours upon hours of homework at night. The questions we are going over right now, if they seem really easy, it's because they are easy. This is what it's going to look like on the exam. These questions I am going over right now aren't to kind of sway you and think, oh, this is going to be too easy. Don't worry. It actually is going to be easy. I took the exam, remember. I got a 5. I know what to expect here. So just keep that in mind. Let's keep going through some questions. A polar function is given by r equals f of theta equals -1 plus sine of theta. As theta increases on the interval 0 to pi over 2, which of the following is true about the points of the graph? R equals f of theta on the xy plane. So another polar equation. Let's have some fun. This time I'm actually going to show you how to graph it because it makes it a lot easier. Let's see. Do I have a space I can graph this? let's see, I can just graph it up here. So we have f of theta. I'm just copying this down right here. F of theta is equal to -1 plus sine of theta. Okay, so what would this look like? We would have, this is our midline because it's -1 plus sine of theta. So because our midline, we have -1. So our amplitude is automatically 1 because there's an invisible 1. So we go down -2, then 0 would be our other line. We have how many points here? Our period is just 2 pi because it's there's no period given. So we have 2 pi. We have pi. We have 3 pi over 2. And we have pi over 2. And so because of the sine graph, we start at the midline, go up to the maximum, then back down to the midline, go down, and go in. So if we were to transform this sinusoidal graph that I just constructed into a polar graph, what would it look like? Well, let's draw our dash marks. Here we go. So we start at the point, this is 0. So we go 0. This is our 0 line right here. We go out by -1. So we actually have to cross the pole because the pole is this in the middle right here. So we actually have to cross the pole, and we put a point out at -1. Lovely. Next one is 0, pi over 2, which is this line right here. And we go out by, 0. So we go to the inside. Pi, we go out by -1. So pi is this line right here. We go out by -1. Again, we cross the pole. And then we have 3 pi over 2, which is this line right here. We go out by -2, so we have to cross the pole again, go up here. And finally, 2 pi, which is back to -1. So we have 2 pi here. 2 pi is this line, and we go out by -1, so we go back here. So what would this graph look like, you wonder? I'll tell you, it looks like a cardioid, like this. Oh my God, that's so bad. But that was what the graph would look like. So I want you to imagine the points on the graph. It's asking us on the interval from 0 to pi over 2. So this interval right here, what's the first ones we sketched? We sketched this one right here. So we're looking at this interval. It is below the x-axis, or the theta axis, I should say, and it is looking like it is increasing. It is getting closer to the origin. So we have to wonder, this is, the points on the graph are below the x-axis, and they're getting close to the origin. I wonder if I can zoom in on this. Yeah. So you can see it is below the x-axis in quadrant 3 and getting closer to the origin. That's what we first started out by graphing, because this is the -1 and this is the pi over 2. Okay, back to the question. Which one is below the x-axis getting close to the origin? Are above the x-axis? No. Are above the x-axis? No. Below the x-axis and getting close to the origin? It's C. Just that. D, the points are in the graph below the x, getting farther from the origin. This is wrong because we're starting at this point and we went to there. Okay. Sorry if we're transforming from a sinusoidal graph to a polar graph. Lovely. Next equation. The increasing function p gives the numbers of followers in thousands for a new musical group on a social media site. The table here gives us the values of p of t for selected values of t in months since the musical group created their account on the social media site. If a model is constructed to represent this data, which of the following best applies to this situation? So we need to construct a model that represents this table. This is what you'll see a lot on the AP exam. So remember, what is the original form for a exponential function? Because this is an exponential function because these aren't linear values. So our exponential function is a b to the power of x. So a is going to be our initial value. What is our initial value? It's at 0. So we get 20 as our initial value. How do we solve for b? Well, b is going to be our growth factor. So the way we do this is we take one point and we divide it by the point before it. So we take 30, we divide it by 20. That is equal to 3 over 2. We take 45, we divide it by 30. Just to check, that is equal to, again, 3 over 2 if we reduced it. And then again, 67.5 over 45, 3 over 2. So our growth factor here is going to be 3 over 2. And then we can just say it's to the t. So this is what P of t would equal. Which one of these is our answer? 20 times 3 over 2 is equal to answer number D here. This is the one we just found. There you go. Pretty easy one. These are no calculator questions right now, just so you guys know. Let's keep going. We're already so close. 1 second. All right, the polynomial function is given by k of x equals ax to the fourth minus bx to the third plus 15, where a and b are non-zero real constants. Each of the zeros k has a multiplicity of 1, and the xy plane and x-intercept of the graph of k is that point right there. A 0 of k is this one. So which of the following statements must be true? So I want you to first understand that the degree of the function, which we see here, is 4. The degree of the function, 4. If the degree is 4, that means there's going to be 4 total zeros. Now, the total zeros here means it is going to be either, they are either imaginary or real zeros. So we already know that we have this 0. And remember that if something is in the form a plus bi, the conjugate, a minus bi, also has to be a 0. So there's 2 zeros that we know are from this form. And then we have, I assume, 2 more real zeros. Because, yeah, we have this one and another one, I am assuming. So the graph of k has 3 x-intercepts. It doesn't. It has 4. Or it has 2, I suppose. This one is a 0 of k. Now, this is the conjugate. Remember, b is this form right here is the conjugate of the one we found earlier. And remember, we know this form. If this is a 0, this has to be a 0 too, which is why b is going to be our answer, but I'll go over really quickly why it can't be the other two. The equation k of x equals 0 has 4 real zeros. No, it doesn't. Specifically, it's not real zeros because we already know we have imaginary. We have this I coefficient here, so we know it cannot be c. The function of k is tangent to the x-axis at x equals 17 point blah, 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 whatever. Can't be that one either. Okay. Why it's B. Okay, guys, we are on to the calculator portion of the exam. Now, for the calculator portion, what I'm going to do is boing, calculator. It's popped on the screen. It's just appeared out of nowhere. There you guys go. I don't really know where to put this. I'm going to be real with you. Okay. Let's start with this first function. The period f is given by f of x is equal to this function right here. Using the period of f, which of the following is the number of complete cycles of the graph of f in the xy plane on the interval 0 to 1,000? All right. So the idea here is that you have to get the period. So basically all we have to do here, because we have 1,000, 1,000 is 0, so that's just 1,000. And once we find the period, we just divide 1,000 by the period, and that would be our answer to this one. So we find how many are in one cycle, which is the period, and then we divide the 1,000 by the amount of cycles. So to do this, what I'm going to do is bring my calculator over here. We are going to plug this function right here into our calculator. And so let's see here. I'm going to go into my y equals. You can also do this on Desmos as well. I'm using a graphing calculator because it's what I've been born with, what I've been used to. You got to remember your calculator needs to be in radians mode right now. The sine of 4x, 2 sine of 4x plus cosine of 2x. Yeah, cosine of 2x. Just like that. Okay, I believe I got that right. So let's look at the graph. Let's see what it looks like. Oh my, it's a repeated graph. So again, I'm gonna probably just zoom this in a little bit. Let's do our y minimum to be like -5, our y maximum to be 5, or sorry, these are x's, yeah. 5 is fine still. Our y minimum is, let's just do -5 and 5 again. I just want to zoom this graph in a little bit to show you. Yeah, that's what our graph looks like right there. So to find the period in our graph, what we have to do is, again, maximum to maximum. So let's find our maximum values here. So let's see here. I'll zoom this in. The way we do this is to go to second and then, we go second and then trace, and then we see all these items. We want to find our maximum point. So I'll click maximum. And then it is asking us to find the left of the maximum. So let's first start by doing the maximum on the right, the far right maximum. Left bound, we have to go to the right of it, right bound, and then we have to guess kind of in the middle. And we get x is equal to 3.49. So I'm going to write that down over here. X is equal to 3.49. We'll just round to 4. Okay, this is what our x is equal to on our first endpoint there. Now we go to the endpoint below it, and then we subtract it to get our period. So let's do second trace again. Go to our maximum. We go left bound. We go right bound. And then we guess in the middle, and we get roughly 0. X is equal to 0.352. Okay, so now what we do, we can do second quit here, and we can just subtract these. So 3.494 minus 0.352 is equal to 3.142. Now, if that the 2 there doesn't really matter because obviously pi is 3.14159, but we just rounded early, which is why we have a rounding error. But 3.14, that is going to be our period. And we know because that's so close to pi, we can just say basically that our period is pi. Lovely. So we know our period is pi. So now let's go. We remember we had to divide this 1,000 by or do 1,000 divided by our period. So let's do that. We do 1,000. Oh my God. 1,000 divided by our period, which was pi, which we figured out earlier. And then what do we get? 318 roughly. That is answer number B. So we can say B is our answer. Okay, let's go into our next one here. Sorry, I'm removing the calculator for just a second, guys. Our next one here is, oh, we don't even need to use our calculator for this one, I don't believe. So the table gives values of m at the selected values of t, which of the following graphs could represent the data on a semi-log plot. So first of all, I want to eliminate some answers. A is not the right answer. Because why? Because none of these axes are logarithmically scaled. None of these axes are logarithmically scaled. This is a linear Cartesian graph, so it can't be this. This one is the same issue. The axes are not, the y-axis on this one is not logarithmically scaled, which is why I have to say no deal for this one. Now let's look at our point, 1, 30. That's the point I'm going to use, 1, 30. Now, we have 2 of these that can be right. So at 1, does it have 30 on the y? No, it's like 0.5, so it can't be this one. Process of elimination is already C, but let's take a look. 1, does it come up to 30? Yes, it does right here. This would be 30 right here. So that's why our answer is C. We will be going over FRQ4 right after this, just so you guys know. We will be going over FRQ4. Whew, this is fun. I'm trying to make sure I got all these right. B, C, all right. Let's do this next one. The table presents values for a function f at the selected values of x. An exponential regression is used to model this data. What is the value of f of 1.5? All right, calculator, come back on the screen. We need you. Can you even run a regression on Desmos? I don't know. This is why I like a calculator better, because I don't know if you can run a regression on Desmos. So anyway, I'm going to put it over my camera a little bit. We're going to copy this data that we just got into we press stat first, and then we press edit, and now we copy the data in. So we get -2, -1, we get 1, and 2. Okay, then we go over 1. Do our y data now. 10, 15, 40, and 56. Is this data right? I believe it is. Okay, so now that we inputted that, the way we run a regression is people are saying that you can run a regression in Desmos. Whatever. This is the way I was taught, so that's how we're doing it. So we do stat. We run a regression by going over to calc. And then calc, it said we needed to run an exponential regression. Exponential regression is this one, number 0 there. So we run a regression. We want to store this in our y values. So we press vars, go over to y vars, y variables, function, and then y1. We can store that in our y1 and then calculate. So we get our exponential regression. If we go under y equals, we see that it is stored there. Cool. So now that we see that it is stored there, let's look at the graph. We can't see it. Let's see. What if we had a zoom standard window? Or maybe because yeah, these points go up high. So let's have our y max be, what's our y max? Y max be 100 or something, and our x max be, our x max is good actually. Yeah, see, so this is what the graph looks like. So now it's asking us to find, if you remember, oh, sorry, something happened here. Calculator, help me out. All right. Now what is happening here is we need to find f of 1.5 here. So we need to find when x equals 1.5. So let's go under trace our second calc again. We go under 0, or not 0, sorry, value, because this will give us the x value we need to find. Value is equal to 1.5, just like that. And what is it equal to? 1.5 is equal to 46.767. So 46.767, that is answer number A over here. And so the answer is A. Lovely, guys. Thank you. I hope you guys are all getting this right. We just ran an exponential regression and found it. Let's toggle my calculator off. All right. The graph of the piecewise linear function f is shown in the figure. Let g be the inverse function of f. What is the value, or what's the maximum value, I should say, of g? All right, so the maximum value of g. Let's take a look. So g is going to be the inverse of f. Now, if you remember, inverse swaps x and y. So if in f we have a point at x, or sorry, I should just do this instead. If we have a point at x comma y, then in the inverse g, we are going to have a point at y comma x. So for this case, we're looking at the maximum value of g. So we need to look at the maximum value of x in this equation. Maximum value of x that we have on this graph is going to be 5, because 5 is the one that is the maximum value shown. So that means at the point 7 comma 5, we have 7 comma 5 in our f graph. We swap this. Oh wait, that's not 7 comma 5. Sorry, that's 5 comma 7. This is for our f graph, so 5 to 7. Then we swap this, and it's going to be 7 comma 5. Of course, this goes into xy. The maximum value of g. G is another way to say y here. So y is going to be equal to 5. So our answer is actually C, which is going to be 5. Cool. All right. Let's see here. How do we want to do this one? Here we go. A large wheel of a radius of 2 feet is, here, I want to zoom in a little bit, is rotated at a constant rate. The figure provides a representation of the wheel in the xy plane with the direction of the rotation included. At time t equals 0 minutes, the wheel begins to rotate. Point P on the wheel is at the start position in the figure. At time equals t, it's the same position as it was at time t equals 0. A sinusoidal function is used to model the y-coordinate of the position P. Which of the following functions is the appropriate model? So the idea here is that we have the function P was in the same position at time equals 0 as it was at t equals 20. So I know that after 20 seconds, it has completed a full cycle. Woo! All right, that's good to know. So how do we do this? We have to find each value. So the amplitude, how do we find the amplitude? Well, pretty simply, it's 2 feet because it's rotated at a constant rate. So it's at 2 feet. Radius is 2 feet. Radius 2 feet means the amplitude is going to be equal to 2. So A is equal to 2. Remember, we are finding the parent sine equation. Yeah, because all these are sines. So what is the parent sine equation? It's going to be f of, let's see if I remember it. F of theta is equal to, gosh, I'm forgetting this. A sine of b theta minus c plus d. We are finding this sine equation. So A is equal to 2. To find B, B is equal to 2 pi over the period. 2 pi over the period. B is equal to 2 pi over the period. So how do we find the period, you may ask? Well, we have to take this 120 and divide it by the 20 minutes. 120 rotations, we have to divide it by the 20 minutes. So we do 120 divided by 20, and what is that? That would be equal to 6. Now, the idea, this is 6 rotations per minute. So because it's 6 rotations per minute, our period here is actually going to be 1 over 6. So that means it's going to be 2 pi over 1 over 6. Now, if you remember, the way we rearrange this is we multiply this 6 by the numerator. So we get 6 times 2 pi, which is 12 pi. The 12 pi is going to be our B. Oh, wait, hold on a second. We don't even have to continue because none of our options have 12 pi as our B. None of them. The only options have 12 pi as our B is going to be D. So D is going to be our answer. Pretty fun. Pretty fun. The answer is D. How many people are still in here, by the way? Oh my God. How is there so many people in this live stream? Okay, it's whatever. We have one last question, guys. We've been going for only an hour. We only have one more question. Okay, so this is our last question in the MCQ portion. A theme park thrill ride involves a tower and a carriage that rapidly moves passengers up and down along a vertical axis, as shown in the figure. The carriage is lifted to the top of the tower, then released to move down the tower. The ride involves 10 controlled bounces from the highest point to the lowest point. Really? Oh, that would suck. Imagine being on this ride. You have to go to the top down 10 times. That sounds like it would suck. Ooh, I don't even want to imagine that. Sorry, off topic. A point X is located at the bottom of the carriage. The height of X above the ground in feet can be modeled by the periodic function h. At time t equals 0 seconds, X is at its highest point of 120 feet. The lowest point for X is at a height of 20 feet. The next time X is at its highest point is at t equals 8 seconds. Which is the end of the first bounce? Which of the following can be an expression for h of t? This is going to be the easiest one. We're going to create a graph just to make this easier on us. Let's create it in black just to make this more easy. So what would be our midline? Or our highest point is 120. So let's write down our highest point is 120. Our lowest point, let's see here, height of 20 feet. Our lowest point is 20 feet right here. Lowest point is 20 feet. So we're going to write 20 feet down here. What's between 120 and 70? Let me do some quick math. 120 and 20 is going to be 70. Okay, that is what is between 120 and 70, or 120 and 20. So now we have to sketch our theta axis, our x-axis. So the next time x is at its highest point is at t equals 8 seconds, so we know that's our period. So that's going to be our endpoint here, 8. And remember, we need 5 points between 0 and 8, so we will sketch out, or we need 5. 0 is going to be included in a point, so we only need 4. So we need 1. Sorry, that's a little crooked. This is 4 points here. So between 0 and 4 this will just go backwards, right? 6, 4, 2, and then 0, of course, is a point 2. So how does this start? A point x is located at the bottom of the carriage. It can be modeled by the periodic. At time equals t equals 0 seconds, x is at its highest point. So it's starting up here. Then at 8, it is at its highest point again. So we start it here. Now we can fill in the points in between. Because we can just surmise, we can guess that it's going to go down here to the midline, then to the minimum here at 20, then back to the midline, and all the way back up. So it would look something like this. Just like that. That is what the graph would look like. So how do we get an equation from this? Well, we remember our, why don't we build a cosine equation? That'll be easier. We can build a cosine equation. F of theta, oh gosh, I will not have enough space to do this. F of theta, theta minus 0, minus c of d. So A, our amplitude, our distance from our midline to our maximum. Our amplitude, our distance from our midline to the maximum, 70 to 120 is 50, right? So it's going to be 50 is equal to 50 cosine of b, 2 pi over our period. This one is going to be 2 pi over our period, which is 8. 2 pi over 8, we can reduce that down to pi over 4. So pi over 4 is going to be our b. Do we have a c here? No, because cosine starts at the maximum, so there's no need for a vertical shift. So we can just say theta plus d. Do we have a d? Yes, d is the midline. It's plus 70. Really hope I don't have to make a sine function here. So 50 cosine of pi over 4 plus 70. That is answer choice number B. Right here. That right there is going to be the MCQ over, I believe. Yeah, this is the entire MCQ, guys. So we went over each question. Sorry, I know you guys, I went through everything pretty fast. If you need to look at the answers or anything, we'll go down these together. I'm just scrolling through these very slowly in case somebody watched the stream VOD later and needs the answers. Let's go to this point. Yep. We're still scrolling. This is great. This is the MCQ. So the stream isn't exactly over yet because I did promise people that I would go over FRQ4. FRQ4 is going to be the AP, is the one everybody is very scared of for some reason. And also the one I didn't make videos for on this channel, so I kind of owe it to you guys to do it. How did you get 8 in the period there? I'll show you. Really quickly, how did I get 8? 8 is going to be the next time x is at its highest point. So it starts at its highest point at t equals 0 right here. 8 is going to be our period because the next highest point, so if it goes to the next highest point, the next time it's at the same point, it's going to complete one cycle. And one cycle is the period. So that's how I know 0 to 8. 8 is going to be my period. Anyway, back to my face. Hi, guys. How's it going? All right. So for this one, we are going to do the FRQ past exam questions, AP Precalculus. So we're going to do FRQ from last year's exam. Just for reference, by the way, I want to let you guys know. You know, it's not. Okay, I just want to let you guys know that it is not going to be, this FRQ specifically is going to have log and trig functions. That's what you're going to be having to solve. I got a 5 on this back when I took the exam, of course, not to brag or anything. The idea here is that you're going to solve logs and trig, like I said. We already have videos on this channel as well of me solving a few questions from FRQ4. So in my trigonometric identities video, I solved the FRQ4. In my log expressions, I think that's topic 2.11 video, I solved past exam FRQ4. So if you need FRQ4, goes to those ones, or we will cover the 2025 one right now. So welcome to the 2025 FRQ. This is the one students were given last year. If you guys want FRQ 1 to 3, we are not going to be doing that here. We will only be doing FRQ 4. FRQ 1 to 3, I already have videos for on this channel, so feel free to watch those videos. They're way better than I could go over in this stream right here, but we will go over FRQ 4 right now. All right. I don't want to cover up anything. So we have directions here. Basically, it's just saying to simplify everything. It's assumed to be in radians, stuff like that. Just simplify everything. That's all you got to do. Okay, I don't actually have a lot of space here, so I'm probably going to have to zoom in a lot. So functions here are given by, sorry, let me do this. Functions here are given by these two functions. So for AI, get it? So for A question I, we have to set g of x equal to 4. So the first one we are given is 4. Here, I wonder the best way to do this. I'm going to write it down first, and then I'll transfer over. 4 is equal to 2 log base 3 of x. Now you might be thinking, because it's a past exam, they're not going to have this in the future. They copy stuff from exams all the time. It's going to have this same structure, so just keep that in mind. Okay, and by they I mean College Board. So let's simplify this down really quick. We can divide the 2 from both sides, so we get 2 is equal to log base 3 of x. Then we can rearrange this into standard form instead of log form. So instead 2 log base 3 of x, this would be equal to 3 to the 2. 3 to the 2, and that's what we're solving for x, which is 9. So the answer here is 9, and yes, you can include the domain if you'd like, which is, it actually doesn't really matter. Okay, so this is our answer. This is all the work you would have to show as well for the first one, AI. This is AI. Now let's go over a double I, or A2. So A2 here is having this question, and we have to set it equal to 3. So let's do that really quick. 3 is equal to 4 cosine squared. Okay, you guys can see that, right? Yeah, you can. Okay. Here we go. So how do we start this? Well, the way we start this, we divide both sides by 4. So we go 3 over 4 is equal to cosine squared of x. Now, how do we get rid of this squared? We have to square root both sides. So we take the square root of both sides, and we get the square root of 3. The square root of 3 over 4 is equal to, or actually, sorry, no, this would be a little bit different. Let me show you. The square root of 3 over 4 is going to be equal to, because we can take the square root of 4, we can't take the square root of 3, unfortunately. So this would be equal to plus or minus, because it's a square root, plus or minus the square root of 3 all over 4. Or sorry, not 4. All over 2, because the square root of 4 is 2. So we only put the square root in the numerator. Okay, and this is equal to cosine of x. Now, if you know your unit circle, you'll see that this is an arc equation once again. What are we solving for? We are solving in the interval of 0 to pi over 2. So we would know that the answers here are, of course, well, from 0 to pi over 2, the only time that cosine is going to be equal to 3 over 2, root 3 over 2, is going to be at the point x is equal to pi over 6. This is an arc equation. We do arc cosine of this right here. And once we get our unit circle, like this one right here, once we figure out our unit circle, we see at pi over 6, it's equal to root 3 over 2. Now, yes, technically we have negative root 3 over 2 at 5 pi over 6, but that is outside of our domain. If you remember, the domain is this, 0 to pi over 2. So that's why this is going to be our only answer here, and this is going to be our solution. Okay, some guys putting A-push jargon that I did in my AP US history stream. Sorry. I'm sorry. Okay, so the functions j and k are given by these two. We're going to do these ones in blue. So these ones, they're just asking us to simplify them down. So I'm going to show you how you do this. Log base 2 of x plus 3 log base 2 of 2. Okay, let's zoom in on this. Okay, so log base 2 of x plus 3 log base of 2 of 2. Remember, what we can do here is the power rule. So we can bring the 2... Sorry, I totally messed something up there. So this is log base 2 of 2. So we can bring the 3 up here, and 2 to the power of 3 is actually 8. So we can do log base 2 of x plus log base 2 of 8. Now, why do we get 8? Because we moved this 3 up here because of the power property, and then we did 2 to the power of 3, which was 8. That's how we got 8 there. And then how can we simplify this down? Log base 2 of 8. Oh, well, this is the product property. So because these are the same base, we can multiply these by each other. So we get 1 log base 2 of, then x times 8 would just be 8x. So this would actually be our answer right here. This is our answer. And yes, you can include the domain here if you'd like. You don't have to, but x would have to obviously be greater than 0. Okay, that is the log question. Can I use the 10% plan here? Get out of my chat. All right. Sorry. So we got to simplify k of x. So let me write it down over here really quick. 6 over tangent of x cosecant squared of x minus 1. Okay, this is what we're simplifying now. This is k of x right here. And this is, of course, b. I forgot to write this, but this is b I. This is b double I. Is I and double I. All right, let's solve this one. So first of all, cosecant squared of x minus 1. What is that equal to? Well, if you know your trig identities, you know that cosecant squared of x minus 1 is equal to cotangent of x. So we can simplify this down, and we can say this is equal to 6 over, it needs to be bigger than that, tangent of x times cotangent squared of x. So that we know that that's what it has to be equal to, because that is a trigonometric identity you guys need to have memorized. 6 over tangent of x cotangent of x. Now I want you to imagine this. This is a little hard to understand. Actually, no. So this can be rearranged. Like, I can do it this way. I'll show you. So 6 over tangent of x. So tangent of x is really sine of x over cosine of x. I'm not going to write the x's because I don't have a lot of space. So tangent of x is really sine over cosine. Cotangent squared of x is going to be cosine over sine multiplied by another cosine over sine. I'm running out of space. That is what cotangent squared of x is. And so we realize the cosines here cancel out, the sines here cancel out, so the tangent of x actually completely cancels out, and we are left with one cotangent of x on the bottom. So we get 6 over cotangent of x. That's one of ours. But what does the question ask us for here? The question asks us, expression in which tangent of x appears exactly once. So we need tangent of x, not cotangent of x. So you have to simplify this down. So 6 over cotangent of x. What is that equal to, you might ask? That is equal to 6 tangent of x. Because cotangent is in the denominator, 1 over cotangent of x equals tangent of x. That's equal to 6 tangent of x. And that right there is going to be our final answer. Okay. Now we have our last question. The function m is given by m of x is equal to e to the 2x minus e to the x minus 12. Find all the input values in the domain of m that yields an output of 0. So we're basically just setting this equal to 0. All right, let's write this all down. What color should we do this in? What haven't we done yet? I'll do it in brown. Why not? Brown seems fun. Function m is given by m of x. So we do e to the 2x minus e to the x minus 12 is equal to 0. Now I'm going to rearrange this to make this easier. E to the x, or sorry, not e to the x, e to the, or would it be e to the x? Yeah, it would be e to the x. E to the x to the second, because this is just the power exponent power property, 2 times x. This is the same thing as saying that. Minus e to the x minus 12 is equal to 0. So basically the idea here is that we substitute in a letter to make this easier. So what if we do this? What if we let e to the x equal something like u? What if we let e to the x equal something like u? So if e to the x equals u, we can bring this over here. We get u squared minus u minus 12 is equal to 0. Now notice this is something that we can factor. So we factor and we get u minus 4 and u plus 3. Now we set both those equal to 0. We get u is equal to, well, here's the thing. U is not our coefficient. It's e to the x, so we get e to the x, not u, is equal to, factor this out, plus 4. We're getting our zeros here. So 4, this is going to be negative 3. And we get e to the x is equal to negative 3. So we just substituted our e back in from earlier. Okay. Now we have to solve both of these. The idea here is that e to the x equals 4. This is not a solution that can be done here. Sorry. Ugh, gosh. Negative 4. Oh my god, this would be, yeah, -3. So, or sorry, I mean e to the -3. Remember, this is a -3. So if we were to put this back in our original expression, this would be an actual extraneous solution because it's a negative. Remember, you always have to check. This is an extraneous solution because if we were to rearrange this into log form, the natural log form, or we can't take natural logs of a negative number, so this is an extraneous solution. But this one, on the other hand, this e to the x equals 4, we can rearrange that into natural log form. So what would the natural log form of e to the x equals 4 equal? It would be x equals the natural log of 4. And that right there, my friends, is the answer. It would not be this because that is an extraneous solution. All right. We just did all of FRQ4. This is it on the screen if you want to read it. Quite a lot. Guys, we did FRQ4. We did it. We did it. I don't even know what to say. So this is, someone give me leaks, please. Please ban that guy. Or sorry, you meant leaks. Oh my god, you're so sorry. Leaks means the leaks for the exam. Sorry, you don't have to ban that guy. Sorry, chat. Sorry, moderator, you're good. Leaks for the exam. Oh my god. Still, don't get leaks. That's bad. Okay. So, the stream isn't necessarily over yet. It's only 7:30. We've only been doing this for an hour and a half. My gosh. So this is all I had planned for today's stream. So what do you guys want me to go over? That is my question. What would you guys like me to go over? I can go over anything you want. Please give me some options in the chat, and then I'll start a poll. Actually, we'll put a poll in, and whichever one gets the most votes, we'll go over that. So everybody, what would you like to go over? Please start putting it in the chat. Please tell me, what do you guys want to go over in the chat? Trig identities, that's a big one, of course. Trig identities. Hard stuff, FRQ 2 and 3. Other end, polar MCQs, polar. Sorry, I just want to, it's all good. Polar, I'm sorry. Polar. I'm seeing a lot of polar. Yo, Mr. Smetus is better. You're banned. Here, how do I start a poll here? Okay. Here, I'm gonna start a poll. What would like to cover? Polar rig identities. Let's see, what else do we got? Don't say binomial theorem. And are we not doing FRQ4? I just did FRQ4. We're not doing the Marshall plan. Rational function. Okay. Try that. I think I just created a poll. Hey guys, what would you guys like to cover? I just created a poll. Jesus. Getting a lot for polar, getting a lot for polar, getting a lot for polar. I'm gonna let the poll run for just a second. An example. Okay. Gosh, all right. You have 721 votes. Sorry, give me 1 second. I want to get a polar equation up for you guys. I just got to make sure to find one first. It takes a second. Give me a graph. R equals 2. plus 2 cosine theta. I don't have examples spilling out of my head here. I just want to make sure I got this. Desmos. Sorry if this is taking a second. Thank you for your patience. Thank you guys for being patient. I really do appreciate it. All right. Let's do this. Everybody. Well, it looks like Polar has won. So Polar has won. So we are going to end the poll. Polar has won. You guys want that. So we are going to go over a polar function. Really quickly, give me 1 second. I got to put this in full screen. All right. Polar functions. Here's what we're going to do. We are going to do this function right here. R equals 2 plus 2 cosine of theta. Now, take this polar function right here. Now, basically, I want to tell you that all questions that you need to solve for polar functions, you can essentially solve by creating a polar graph. If you know how to make a sinusoidal graph and transfer that to a polar graph, you're going to be able to answer all questions. So here's what we are going to do. We are going to create a sinusoidal graph. So let's write down a graph here. Now, how do you create a sinusoidal graph? We have 2 plus 2. So 2 is our midline. We know 2 is our midline. How do we know that? Because it is our D right here. D could also be anything. It could be plus 2. It doesn't matter. So 2 is our midline. D is 2. Now, our amplitude is 2 because it's going to be the one multiplying here. So 2, so that means we have to go 2 up, and we get 4. That also means that we have to go 2 down, and we get 0 here. All right. So how do we find our period? Well, pretty simply put, sorry, 1 second. Sorry. So pretty simply put, the period is whatever's in here, and whatever's in here is equal to the to b. So b is equal to 2 pi over the period. You would just have to reverse engineer that. Luckily, we don't have any number in here, so we just know 2 pi is our period, because it would just be 2 pi over 1, so 2 pi period. So we can write 2 pi. Then we get we have to get 5 points. 0 is already a point, so we just have to do 4 in the middle here. So 1, 2, no, a little too much. 1, 1. Here. OCD is coming up. So what we want to do here is that 2 pi, half of that is pi. Then we have 3 pi over 2 and pi over 2. So now that we've made all of our points, we know how to construct this. It is a cosine graph. A cosine graph starts at the maximum point. The maximum point here is 4. So it's going to start at 0, 4. And then a cosine graph goes down, and then it goes back up. So we can model the points here. We know that we can do this. This is totally allowed in calculus, or precalculus, I should say. You can totally do this. This is totally allowed. And then the cosine graph is going to look like this. And of course, it would keep going on and on forever. So now we have sketched this graph. So now how do we transfer this to be a polar graph? Here's the idea. Set our axes again. Polar graph, it's going to go out by 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So your polar axes here, basically all you do is copy the Cartesian points and copy it over to the polar graph. So here we start at 0. Our line here is 0. This line, here, let's write this in black actually. This line is 0. This line is pi over 2. This line is pi. This line is 3 pi over 2. So imagine it's kind of like the unit circle. So we start at 0, our point here, and we have to go out by 4. So 0, 1, 2, 3, 4, right here. Lovely. And then we go to our next point, pi over 2, and then we have to go out by 2. Pi over 2, we go out by 2 right here. So what do we do here? We sketch our line out to pi over 2. Okay, our next point is pi, but we go out by 0. So pi, but we go out by 0, so it's just going to be in the middle right here. So we sketch a line to the middle. And then we do 3 pi over 2, which is this line, right? Yeah, then we go out by 2. So we go right here once again. And then we go back to 2 pi out by 4. So it's just this same point. So we sketch it to go back. Now this is oh my gosh, this is a cardioid. Now, how do we use this to answer questions? Well, the idea here is that if you want to know whether something is increasing or decreasing, look at the sinusoidal graph. Like, let's say if this one is labeled E. Like, let's say this interval is labeled E. So we know that that interval on the sinusoidal graph is this. So if it was asking us, is this decreasing or increasing? If we just had the polar graph, if we were just looking at the polar graph here, how are we going to know if this interval E is increasing or decreasing? We don't. But what we can do is, because we have the sinusoidal graph, we see we see this interval E is going down to 2. That means it is decreasing. We know it is decreasing because we have our sinusoidal graph. That is why you need to know how to sketch polar and sinusoidal graphs. This is basically the big idea for polar graphs, everybody. We're at 100 minutes. Nice, we did it. Now, what would you guys like to go over now? Yo, are there cardioids on the exam, son? Yes, there are cardioids on the exam. It's probably the most common polar function you'll see. You'll also see, of course, roses and limaçons as well, stuff like that. It's trig. Be sure. Yeah, trig identities. Can you explain how to solve FRQ inequalities, please? Oh my God, there's so many chats. I'm not used to moderating a stream with 1,000 people. You carried, thank you, of course. Trig identities, trig. Seeing a lot of trig identities. I think let's just do trig identities. For you guys that are asking for FRQ3 or FRQ2, FRQ1, anybody who is asking for those FRQs, I am not going to go over them on this live stream. The reason I'm not going to go over them, sorry, let me see your face. The reason I'm not going to go over them is because I have videos on this channel for that. They're only 5 minutes long each. They're great videos I made. I recommend you watch them. FRQs 1, 2, and 3. There are videos on this channel that you guys can watch for them. So please watch those videos. If you want FRQ4, I already went over it in this stream. In fact, I think I still have the page open. Yeah, this one right here. I already went over the FRQ4 in this stream. You're going to have to rewind if you want to see it. But watch those videos if you want that. We're going to go over trig identities next. So back to my face. I got to delete some stuff. Sorry, add out. Hope that helped clarify polar functions for you guys. You just need to understand how to graph them. And once you understand how to graph them, it makes this so much easier. All right, I'm erasing all the polar work we just did. Okay, what was I going over again? Trig identities. Yeah, 1 second. Me. One second, sorry guys. I'm just taking a second here. I have to make sure I get everything set up. It's really difficult to moderate a live stream and also work on a computer. Okay, let us have some fun now. We pass in tomorrow, guys. Thank you, moderator. I appreciate it. Welcome back. So we're going to go over trig identities now. So trig, where's my trig? You guys know what that means. Trig identities. Identities. Hope that's how you spell that. I'm not sure. Whatever. Trig identities. All right. So your basic trig identities is the easiest one, which is, this is the one that's going to pop up the most. Sine squared of x plus cosine squared of x is equal to 1. Now, this can be rearranged, like 1 minus cosine squared of x is equal to sine squared of x, or 1 minus sine squared of x is equal to cosine squared of x. It can be rearranged, so you have to be able to spot this. All right. The other Pythagorean identities are the 1 plus ones. 1 plus tangent squared of x is equal to secant squared of x. So tangent is secant. 1 plus cotangent squared of x is equal to cosecant squared of x. Those are your basic Pythagorean identities. Now let's really quickly talk about the sum and difference identities. So sine of a plus b is going to be equal to sine of a multiplied by cosine of b plus, because it's a plus, cosine a sine b. Now, we got to do the difference too. Sine of a minus b is equal to sine a cosine b, but now instead we have a minus sign, so cosine b, or cosine a sine b. That's your idea for sum and difference identities. Oh, sorry, we didn't even do the cosine ones, did we? Well, yeah, let's just do that really quick. Cosine of a plus b is equal to cosine. Cosine is specific because it has the two ones on one side. So cosine a, cosine b, minus sine a, and then sine b. But notice how it's opposite. So it's minus when it's plus. So this one is going to be the same one, a minus b. It's going to be the opposite sign. So cosine a sine b, or not sine b, sorry. It's cosine, cosine, sine, sine. Cosine, cosine, plus sine, sine. Okay. Then we have our double angle identities. Now, these can be derived in many different ways. The basic one to know for your exam is that, let's see this in green, sine of 2 theta is equal to, or not 2 theta, we've been doing x this whole time. 2x is equal to sine, or sorry, I should say 2 sine of x cosine of x. Don't ask me why, it just is. And then cosine's double angle identity is the same idea, just a little bit different. Cosine of 2x is equal to cosine squared of x minus sine squared of x. And these can be derived in many different ways. Like we could also say that this would be equal to 2 cosine squared of x minus 1 if we used our Pythagorean identity from earlier. Or we could also say that it's equal to, I don't know, 1 minus sine, or minus 2 sine squared of x. So these are your trig identities. If you need a screenshot or anything, these are also readily available on the internet, so no need to do anything crazy. But these are your trig identities that you would need to use. Yeah, what else do we got? What else do we got, guys? What else do we need to go over? Anything? It's the night before your exam. I'm here to help. I want to help in the best way I can, so please just let me know. Sorry, I'm trying to see my live chat. There we go. Who is Big O? I'm not sure. Log? We could go over log rules. Maybe I could put it on the side of the trig rules. Coterminal angles, twin. Coterminal angles are, I mean, they're pretty easy. You're not going to see much of the coterminal angles on your AP exam. The idea is that you just have, if you have an angle at sine of 30 degrees per se, the coterminal angle is going to stretch around the whole entire graph and go back here. And so sine of 30, if we did a whole rotation 360 degrees, we get back here, we get to, this would also be equal, a coterminal angle of this would be 390 degrees. So not that hard. You won't see much of that on your exam either, so you're all fine. FRQ4 would also be nice. We already did FRQ4. Here it is. That's me completing FRQ4. We already did it. Rewind the stream. Can we do Pascal's triangle? Forever, Ivonic. Thank you for the $4.99. I appreciate it. You asked, can we do Pascal's triangle? I suppose we could. See, the thing is, I want to go over Pascal's triangle, but it's not going to be worth much on your exam. All right, I'm going to erase this all. Sorry, guys. Anybody who's reading it, I'm erasing it all. So it's not going to be that covered on your exam because, like, sorry, I'm going to bleed into calculus territory here. Pascal's triangle is very much its own self-contained thing, and it's only in one topic where you also cover polynomial long division and stuff like that. So you don't need to cover Pascal's triangle that much because you're not really going to see it on your exam. But I mean, there might be one question though. So if you guys want to go over it, I can. But I just saying. Big equations plus identities. Yeah, the thing is, Pascal's triangle is not that relevant for the exam, which is why I don't want to send here. Hop on Fortnite, get out of this chat. FRQ interpretations, end behavior, arithmetic sequences, a lot of things. So first of all, I'm just going to go over some basic concepts here. Arithmetic sequences, arithmetic versus geometric sequences. Arithmetic sequences, don't worry about the arithmetic sequence equations. Just worry about an arithmetic sequence is y equals mx plus b. It's a linear function. A geometric sequence, geo, is going to be modeled by the exponential function y equals ab to the x. Don't worry about the geometric sequence equation. Don't worry about the g sub 0 equals g sub 1, whatever. It doesn't matter. Yeah, it's not that important for the exam. I apologize, dude. I'm not going to go over Pascal's triangle. You can watch my topic 1.11 video. I do cover it in there, but thank you for the $4.99 either way. Properties of logarithms and exponents. All right, why don't we go over that? Oh my gosh, that's a big one. Really quickly, I'm going to go over properties of logs and exponents. Sorry, I was reading some idiot in chat. So we're going to cover the different rules of exponents really quick. And that is, let's start with this basic one. A to the m multiplied by a to the n. What is that equal to? That would be equal to a to the m plus n. Lovely. Actually, I think a better way to go over this. Instead. Sorry, my chat's just watching me type on a keyboard. Sorry. Let's instead of doing the exact properties, why don't I just show you examples? I think that's an easier way to frame this. So, product rule. Say we had x to the third multiplied by x to the fifth. What is that equal to? You have to add the exponents. That would be equal to x to the eighth because we're adding exponents. What about the quotient rule? What if we had x to the seventh all over, what do we say? X to the 2. This one, because it's fractions, we have to subtract the exponent. So we get x to the fifth. Lovely. What about the power rule? What if we have x to the 3 to the 4? If we have that, then we have to multiply the exponent. Oh, yeah, I forgot about that. My gosh. X to the 12th. Thank you, Michael Joel Roth, for the $2. Converting polar to rectangle and vice versa. Yeah, I'll go over that in just a second. Give me 1 second, though. I'm going through this. Okay, yeah, we multiply the exponents because it's a power to the power. If we have a negative exponent, x to the negative 3, that is equal to 1 over x to the 3. If we have a fractional exponent, x to the, let's say, 3 over 2, what would that be equal to? That would be equal to the square root, the denominator, square root of x to the third. We take the denominator's root, and then we add the exponent on top. What about we transition to log rules? Let's see if I can get this. Log base log of x minus plus, we'll do plus log of y. Sorry. Log of y is equal to just one natural log, or this will be common log of log x over y. Or sorry, not x over y, it would be x, just xy. Sorry, I know my camera's blocking this. Give me 1 second. There we go. This is the product rule on top, of course. The quotient rule, of course, is going to be the property, it's just the opposite. So log of x minus log of y is going to be equal to log of x over y. This is the quotient rule, the opposite. Then we have, say we had like 3 log of x. This is equal to log of x to the third, because we can move this onto the front of that's the power property. Yeah. I don't really know. I think that's pretty much it. I mean, I could go over the change of base formula. What log base 2 of 7 would be equal to log of 7, a common log. This is a different log here, over log of 2. Could also be natural log, or whatever you want. But yeah, here are your formulas. Oh my god. Sorry, my brain is just not computing. So we've been doing this. Thank you for teaching. You are the go. Also, can you go over the LEQ? LEQ for what? AP US History? That exam's already over. No thanks. But thank you anyway for the $10, Legendary. I appreciate it. Okay. Let's see here. Hi, what are some niche things about precalculus? I.e., if we cancel out the whole and we are still left with a whole in the denominator, it will now be considered a vertical asymptote. No, if you cancel out the whole, then that would mean that it wouldn't be a vertical asymptote. Like, I think you're asking, like, sorry, I'm deleting all this. Sorry, guys. Hope this was beneficial for the people who needed it. Rewind if you need to screenshot it or whatever. Come on. Delete. I have 1,000 people watching me right now. I need to get this. Okay, so this guy was asking if you have, like, I don't know, x plus 1. Oh my gosh. X plus 1, say x minus 2. And then that's all over something like x plus 1, x minus 3. So look at this. We have a 0. This is going to be a 0. This is a 0 right here. Here, let's actually label these with a different color. So this right here is going to be a 0 because it is in the numerator. This right here, these two that cancel out, these are going to be a whole. These are going to be a whole. Now, because they're a whole, they're not a vertical asymptote. This one, because it's by himself, this is going to be a vertical asymptote. So this is the idea. This is going to be a whole. This is going to be a vertical asymptote. This is going to be a 0. That is the idea here. Thank you, Dave Pringle Bingus, for the 199. How do you find slant asymptote and slope? Slant asymptotes come from when the numerator is bigger than the denominator. So you say you have x squared plus 2x minus 1, and that's all over, let's just say x minus 2 or something. Or actually, no, that's a numerator. Let's just say, I don't freaking know, x plus 7. That's not going to be 1. So the way to find the slant asymptote here is to do polynomial long division. So you would have to set this up, x squared plus 2x minus 1, and we do x plus 7. This is not a horizontal asymptote. This would be polynomial long division. So I don't know, we get x squared plus 7x, and this would be minus. So these cancel. 2x minus a negative 5x. You can't see this, can you? Negative 5x, and then we add the minus 1 down here, and then to get the You get a 7. You get the idea. This would be how we would compute our slant asymptote right here. Okay. What else should I talk about here? I'm not sure. 5x. Sorry, I just want to make sure I complete this. This is annoying. 5x. Not 5x. Just 5. 5x minus 35. Thank you. My channel member, or not a channel member, sorry. Thank you forever, Yvonne. What if there is a 2x plus 1 in the denominator? What if there are 2x plus 1s in the denominator? Sorry. That is a good question. I wonder what would happen if we plug that in on Desmos. I am curious. Let's take a look. Sorry, this is the one we did earlier. I'm curious what would happen. So let's say we had x plus 3, or x, what was the one we did? X minus 1, and then we did, I don't know, x plus 1, or let's say x plus 2, then x, and then 2x minus 1s. Would it just make it x minus 1? Interesting. So we have x minus 1, which is this point right here. Oh, sorry, this is by pi axis here. Yeah, so it doesn't create a vertical asymptote. It would be this. So sorry, it does create a vertical asymptote. So I suppose that means the vertical asymptote cancels out the whole here. Yeah, notice how when it's just 1, it would just be 2 graphs. But when we add the second one, it turns into 3 graphs. So just notice that. That's what that guy was asking for. Polar graph with b value, even number. Sorry, I'm going to polar graphs right now. Let's go over to polar graphs. Let me switch back to my face. So you guys wanted, I think a few of you might have asked if you wanted to switch from rectangular coordinate systems to the polar coordinate system. I said I would go over this to a guy who donated, so we will do that. Give me just 1 second. I got to make sure all this is erased on my side. By the way, guys, really quickly while I set this up, do you mind telling me where you guys are all taking your exam tomorrow? Where are you guys all from? I'm from the state of Colorado personally. What about all you guys? Where are you from? Tell me about it. We're going to do rectangular and polar conversion right now. Really quickly, I just want to know, where are you guys from? Please tell me. Shout out to my homie Daniel, help with trig identity. Shout out Daniel. Just 1 second. New York, Virginia, New York, Texas, California, North Carolina, Arizona, Michigan. Wow, look at all you guys. We have such a diversity of people in here. This is crazy. Okay. Such a diversity of people. My gosh, I would have never imagined. North Carolina, Michigan, New Jersey, Florida, Texas, Austin, Texas. Wow, we have a lot of Texas in here, I'm noticing. Florida, Texas, Massachusetts, New Jersey. Oh my God, I'm also from Colorado. GG, we both live in the same city. Or maybe not the same city. I live in Denver, Colorado, but yeah. Hawaii. Oh my God, we have Hawaiians in here. No way. Florida, Louisiana. All right. I'm sorry, I'm getting sidetracked here. So we're asking how we convert from a polar coordinate system to a rectangular system. The idea here is that you have a point in the format. Sorry, I want to make sure I get this right. You have a point in the format of x comma y. So let's say you have the format of x comma y. Now, how do you convert this into polar coordinates in the format of r comma theta, because that is polar coordinates. Memorize unit circle by learning the triangles. He is right. I will go over that in a second. So how do we convert between these two? Well, basically put, r is going to be equal to the square root of x squared plus y squared. Thank you for the $2, by the way, forever, Ivonic. So that is what r is equal to. Now, it gets a little bit different here. If x is greater than 0, then theta is going to be equal to So if x is greater than 0, theta is going to be equal to inverse tangent of y over x. Thank you for the $4.99. Thanks for the help, King. You are very welcome. Thanks for the $4.99, Zoe. I appreciate it. Okay, so this is what, if x is greater than 0, theta is going to be equal to tangent, inverse tangent of y over x. If x is less than 0, then theta is going to be equal to the same tangent of y over x. But this time, what we do is we add pi. We just add a pi at the end. This is your idea of how to switch between rectangular and polar coordinates. If it is, the idea is that if it is just the r comma theta you're given and you need to swap back to the x comma y, let me show you how. The way you do it is with these equations you were given earlier. X equals r cosine of theta, and y equals r sine of theta. So if you're given r and theta, and you're trying to find xy, you just use these equations to get back to xy. If you're given xy and trying to go over to r comma theta, these are the rules you must follow. They're saying, give an example. It's going to take a second if I give an example, but I could if you guys like. Oh my gosh. Jesus Christ. It scared me. I guess I could give an example. Like, would you guys like an example for this? Yeah, I'll give an example. All right, let's do it. I have to delete everything so I can actually have space to do this. Sorry if I missed any donations this stream, by the way. I know I've been pretty locked in, as the kids say these days. All right, so why don't we have the point, I don't know, -2, 2. Now, what if we needed to convert this to the coordinate point r comma theta? Well, here's what we do. First of all, we need to do the r equation. Here, actually, I don't like this. Let's do -2, 2. Sorry, I just wanted it in black. All right, so now we need to do our r equation. So r is equal to the square root, oh my god, r is equal to the square root of x squared plus y squared. So r, let's plug in our values. X, obviously this is x, y. So r is equal to -2 squared plus 2 squared. So r is equal to the square root of 8. The square root of 8 can be simplified to 2 root 2. Lovely. All right. Then if we want to find theta, we need to figure out which one we're using. Now, is x greater than or less than 0? X is less than 0. That means we have to add pi to our tangent function. So theta is going to be equal to, all right, theta is going to be equal to tangent -1 of, remember, x over y, or is it, sorry, no, it's y over x, I mean to say, y over x, but then this one is going to be plus pi. So we get theta is equal to tangent, or inverse tangent, I should say, of y, which is 2 over -2, plus theta, or plus pi, I mean. The theta is equal to inverse tangent of -1 plus pi. Now let's look on our, I wonder if can I pull out a tangent unit circle? Let's see if I can. Tangent unit circle. I think I can. Hold on. This will be cool. Open image, a new tab. Yeah. So, yeah, I can. Look at that. That's a tangent unit circle right there. So we are looking, where are we at? This one. So we are looking for where tangent is equal to -1. Well, let's look here. On the graph, tangent is equal to -1 at 3 pi over 4. And this one, quadrant 4, 7 pi over 4. So your idea here is that, oh my gosh. Sorry, something just flew into my eye, I feel like. Ugh. Sorry. All right. What was I doing? Yeah, tangent is equal to -1 at 4 pi over 4. Terminal ray, please, before I leave, I have to sleep. I understand. We'll see what I can do. Oh my gosh, I can't. It keeps trying to close on me. There we go. No, that's not the one. So we have to find out where tangent equals -1. Sorry, 1 second, guys. I just received something on my end. I got to deal with a live chatter really quick. Convert to comma 2. Coordinates. Sorry, I understand if you were waiting. I will get to you in a second. Okay, so we're looking for where tangent is equal to 2 over 2. And we see this here at actually this point right here, 7 pi over 4. Now, you might be asking, why would we do it? Why don't we do 3 pi over 4 here? Well, remember, inverse tangent's restricted domain. Inverse tangent can only exist between this one, 3 pi over 4, 3 pi over 2, I should say, to pi over 2. That is the restricted domain of tangent. It can only exist in quadrants 4 and 1. So it can't exist in quadrant 2. That means this is going to be our only answer. Where was it? Oh, I missed it. -1. 7 pi over 4. Now, we don't write 7 pi over 4. What we write is negative pi over 4. Just to be easier, because obviously going down, it would be negative. Going all around would be 7 pi over 4. So what we write here is negative pi over 4. Okay. So, oh my gosh, why is this so hard? There we go. So we get theta is equal, I guess we could just write the 7 pi over 4. No. Tangent squared of x, sorry, we've just figured that out. It was 7 pi over 4. Not 7 pi over 4. I said it was negative pi over 4. Okay, that's why we write negative in this case. And then we have to add pi. So if we add pi to this, we get theta is equal to, what would that be? 3 pi over 4? Yeah, all right. So we have completed the conversion. So we got -2 comma 2, and we have the r, we have the theta. So our answer here is actually just 2 root 2, because that's our r, comma 3 pi over 4. This is r and theta. So this right here is our answer. So that's how we just converted. That's the example you guys wanted, right? There's your example. Gosh. What is going on here? Thank you for the $1 A1 Gutier. Theta is equal to 3 pi over 4. No, yep, you got that. 3 pi over 4. Trig equations plus inequalities, please. I have to go to bed. Okay. This guy asked me to cover the terminal ray really quick. I'll just really quickly explain. Terminal ray. Your idea with trig, you have a graph. You have a big circle. Now, you have a point that's coming through here, and it's intersecting. This is a terminal ray that will technically go on forever, and what it creates here is a right triangle with the x-axis. Then you can get the sine and all that. So terminal ray is really just saying that it intersects that point on the whole circle, and that point is point P. Yeah, that's just the idea. Okay, you guys, I understand we're getting close to some people's bedtimes if you live on the East Coast. So specifically, I'm going to go over one more thing for you guys, and that thing is going to be trig equations. We're going to go over a trig equation together. I'm hoping you guys have already memorized the unit circle. I'm hoping you guys have already memorized a lot of stuff, but I think you were doing mostly good. Sorry, I got to delete all this so I can put a trig equation. In fact, I need to get a trig equation, so let me go to my extended notes where I'm sure I have one. Equations. What R is the domain for inverse trig? Okay. Equal to 0. Sorry, I'm just getting an equation from my extended Google Drive. can you go over sinusoidal graphs, please? I go over that in my FRQ3 video, so feel free to watch it there. But anyway, we are going to go over one last thing for this stream because I know some of you have to get to bed and I don't want to keep you up waiting. So we're going to go over one more thing, and that is a trigonometric equation. We're going to go over this one. 2 sine to the third of x minus 3 sine of x plus 1 is equal to 0. How do we solve this? Well, the idea here is we just completely get rid of the sign. We just completely get rid of the sign. Or sorry, not sine to the 3. I don't want to do sine to the 3. That's really difficult. I want that to be sine to the 2. So the idea here is we completely get rid of sine at the start. We substitute it out. So we get 2x squared minus 3x plus 1 is equal to 0. So first off, we completely get rid of sine at the start. So we just substitute in sine. Sine is x in this point. So this is, we can just treat it like a normal quadratic. We can 2 times 1, blah, 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 3. If we factor this, what would it be? It would be 2x minus 1 and x minus 1. This would be our factored form of this. But remember that this needs to be, or I guess we can solve this first. So we get x is equal to 1 over 2. And x is equal to 1. But remember, it's not x, it's sine. We forgot about it earlier, but we need to bring it back. So we get sine x is equal to 1 over 2. We brought it back, and we get sine x is equal to 1. Okay, so how do we solve this? We use our unit circle. So what's from the unit circle? We know sine x equals 1 over 2 is going to equal, off the top of my head, it's going to be pi over 6 and 5 pi over 6. That's what x is going to equal. On this one, when sine is 1, it's going to equal blah, 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 pi over 2. Okay. And the idea here is because we have sine x of 1 over 2, we would put a plus 2 pi k on both of these. We get plus 2 pi k. Now, why do we do this? Because we don't have to adhere to restricted domains, so we have to put a plus 2 pi k on both of these, plus 2 pi k. Just so you guys know, we have to do this on both. I already went over the Pythagorean identities. I apologize, but yeah, all right. Yeah, how many people do we have in the stream right now? Let me go check. Of like 900 people in here. That's kind of crazy. Okay, everybody. I need you guys to rock this exam, and I need you guys to get a 5 on this exam too. I want to point out that when I walked into my AP Precalculus exam that I had 2 years ago when the course first started, I took the AP Precalculus exam, and I expected I was going to get a horrible score. I walked in there, and the exam was so easy. It was so much easier than you would imagine. So I did the whole exam, and I don't want to say it was easy for me. No, I walked in there, and we did the MCQ. We were getting 80 questions for the multiple choice questions. We were given 80 minutes. Everybody finished a half hour early. I look up after I finish, everybody else has finished too. We just had to sit there for a half hour doing nothing. Why? Because it was so easy. Okay, I'm not going to try and say easy exam. If you don't get a good score, you're bad. But come on. You guys got this. Have faith in yourself, and you'll do the best. Watch my videos if you need them. Watch them. They're there for you to access. And all the topics that you guys are asking are videos I already made on this channel. Check my full AP Precalculus playlist. In fact, see if I have that playlist here. Yeah, my full AP Precalculus playlist over here. It is right here in my playlist. You can take this playlist. You can watch all these videos, every single one. Like a lot of you guys were asking to go over sinusoidal functions. Well, I go over it right here. Or, oh my God, you guys can't see this. You guys were asking for go over sinusoidal functions. Well, we can go over it right here. I go over it right here too. Sorry, you guys didn't see the playlist. I have one, I have every single topic in here. I also have the 3 FRQs if you guys want to go over them. FRQ4 is when this stream. You're going to have to rewind. Thank you for the 199 Vital Penny. Thank you. You're very welcome. Okay, I have the whole course covered here. If you guys need help, trig identities, there it goes. Cosecant, secant, tangent. I have videos for them. Logarithmic functions. Every single thing has videos for them. This took so long to make. So please, walk into that exam tomorrow and rock it. For me, for yourself, but also for me, because I put in a lot of effort for these videos, guys. I believe in you to do good on this exam. Okay, and with that, guys, I don't think I have much more to say. Tune in to any of the other courses I have on this channel. I do AP Psychology, AP US History, AP Calculus. If you're taking Calculus next year, I have videos up for that. And AP, I think I already said Psychology, but you guys get the idea. All right. Thank you guys for joining me. I'm going to do a YouTube short tomorrow morning, wishing you all luck. But everybody,